Okay, good morning, everyone. We're now looking at chapter 30, the final chapter of your work on solids and volumes. Just waiting for it to come up now. These useful videos are obviously useful to go through and check any questions you're stuck on, as well as mark your work. So if we look at question 1, first of all, you've got these 3 types here of solid. And I'll just move it down so you can see it okay there. And you've got here, you've got to label them as a cylinder, cone, prism, pyramid, or other solid. Okay, so we've got E here as another solid. It doesn't really meet any of them. B, this is a cone because it's got a pointy bit at the top. You've got A here, which is a cylinder, a rounded base. Could be B or D. It could be a cone or a prism. This one here could be A or C, so it could be a cylinder, or it can also be a prism, and A and C there as well. Next, you've got to find the surface area, okay, not the volume, the surface area there of the shape. So you've got to work out the area of all the faces on the cube, okay, and then add them up, okay. So if we start with this first one here, this face, it's 5 meters across, but 2 meters up. Okay, so 5 times 2 is 10, and there's 2 of them, so it'll be 20 centimeters, opposite faces. Next, you've then got the top here. That would be 5 across by 3. Okay, 5 across by 3 is 30. Then you got the little side ones here as well, which are 2 by 3. That side and that side. That's 12 centimeters. When you add it up, then the total surface area should be 62 centimeters squared. Then you got a pretty easy one. You find the volume of the figure. You just got to times those 3 numbers, 20 times 8 times 2. And that would be 320 centimeters cubed. Remember the cubed bit there as well. We got some conversions next. So remember when we're working this out, if I just zoom in a little bit here so we can see a bit better. We're converting meters cubed to decimeters cubed. So when we do that, decimeters are smaller, okay? Then we just times it by 1,000. Because remember, when you see meters cubed and you move to something, a smaller measurement, just 1 across, it's times 1,000. So 3 times 1,000 is 3,000. Then you got 30 decimeters cubed. The next one down from decimeters is centimeters cubed. You times 30 by 1,000, that's 30,000. Then you've got centimeters to millimeters. Now, this is a decimal point. So another clever way when we times by 1,000 is move the decimal point there 3 places, okay, to the right. So if you jump over 3 times to the right, 0.3 becomes 300 millimeters cubed. This is going the other way. It's going from smaller measurements to bigger measurements. So we're going to use divide here, and they're all cubed, so we divide by 1,000 in each case. Or we move the decimal point 3 places, okay? This time we go 3 places to the left. All right, so 5,000 divided by 1,000 is 5. 500 divided by 1,000 is 0.5. And 50,000 divided by 1,000 is 50. Okay. Then you've got a basket shaped like a cube. One side is 30. Find the volume of the basket. So 30 centimeters is the same as 3 decimeters here. Okay. And we know that 1 decimeter is the same. 1 decimeter cubed is the same as 1 liter. So all we do is, because it's a cube, every single side is the same size. So 30 centimeters becomes 3 decimeters times 3 decimeters times 3 decimeters. That gives you 27 decimeters cubed. Remember, a decimeter is the same as a liter. So it's 27 liters is your answer. And then we've got this rectangular vegetable patch is 4 meters long, 3 meters wide, and you've got this 20 centimeters thick. So what might throw you here is the measurements. You go, you've got meters here and here, and yet you've got centimeters here. Let me take this cube off, a lot of dots on the screen. So we got to convert the 20 centimeters into meters. So what we do is we do 4 times 3 times 0.2, and that'll give you 2.4 meters cubed. Quite a sneaky question that, because you have to remember to convert. This one is a dice, so the opposite sides add up to 7. Miss up the put in the filling points. There's your answers there. This one looked tricky, but if you've got it done, well done. It's imagining that you've got this kind of like, looks like a Rubik's Cube, doesn't it? And it's saying it's all been dipped in paint, and you've got all these cubes here, okay, in your Rubik's Cube. So how many of that have 3 faces painted? Okay, so let's take this corner one here. This has got 3 faces painted, hasn't it? On there, the front, and at the top, and on the side, 3 faces. So how many are like that? Well, every corner is going to have 3 faces painted, isn't it? That one down there, and then that one down there, and then up there, and then over there, and then over there, and then behind here, and at the back. So there are actually 8 corners on a cube, and those will have 3 faces painted purple. Next is how many have 2 faces painted instead. So a good example is this one in the middle here. That's got the one there and the one above at the top. It's got 2 faces painted. How many are like that? All right. And if you're working out, then there's one there, and there's one down there. There's one across here, one up there, one over there. They've all got 2 faces painted. Okay, and that adds up to 12. How many have only got 1 face painted? Well, that would be 6 of them have only 1 face painted. So this would be right in the middle of the cube. That can't get it quite there, but you see that kind of right in the middle of the Rubik's Cube there. That's only got 1 face painted. All right. Same over here. That middle one there has got a face painted. Underneath there's one. Basically every face, the middle one, and that's 6 of them has got 1 face painted. And how many have got none of the faces painted? There's one right in the middle of the Rubik's Cube you can't see, but it's in the center of it all, hidden away. There's 1 face there painted. All right. Same principle really for this rectangular cube. How many have got 3 faces painted? Well, the corners have. There's a good example. That one there, and that one over there, that one there, that one there. All right. There's 8 in total. How many have got 2 faces painted? Well, I'll just point a few good ones. That one, that one, that one, you know, go in there. They're kind of in between the corners. That comes to 16. How many have only got 1 face painted? 6 of them. So we've got, have a look there. That's 6 there. And then how many have got none of them? Well, how many have got none of the faces painted? It says none. All right. What's next? These are these random multi-sided shapes called platonic solids. Tetrahedron, hexahedron, octahedron, dodecahedron, and icosahedron. And you just work which of these that like folded out would make which shape. That's a hexahedron, octahedron, icosahedron, dodecahedron, tetrahedron. And then you got to work out for each how many faces it's got. So let's take an example here of the tetrahedron. How many faces are there? So this tetrahedron here has got 4 faces, all right? The 4 sides on it. The hexahedron, so remember hexa means 6, is this one here. So it's like a cube. It's got 6 faces. And the octahedron over here has got 8 faces. Octa means 8, like octopus has 8 legs. The vertices is how many corners has it got? So look for that, all right? There, the answer's 4, 8, and 6. And the edges are like the line bits, okay? So like that's a line there, for example, and that's a line there. How many edges has it got as well? And there your answer is 6, 12, and 12. That was a tough one. The maths golf, you don't need to worry about that. That's just like a fun in-class activity to do, all right? So that's your guidance for today, guys. We're going to have a mock test on Monday. So have a review of what we've got. To make it a level playing field, we're going to have it as an open book test, so you can refer to your books during it. But I'll set a time limit for the test that you have to submit it to me by. Okay, so yeah, good luck with that. Hope that was a useful guide for you. And yeah, thank you very much.